Hey everybody, this is another part of Newberry Volcano, National Volcanic Monument. Beautiful cinder cone on the horizon called Lava Butte. It's been very hot here today, over 100 degrees. So we've waited until about 7 p.m. local time to take a walk on this little trail. For 20 years I taught a field methods class down in the Owens Valley of California, Geology 210, at the White Mountain Research Station outside of Bishop, California. It took us 2 days to drive down from Ellensburg, Washington to Bishop, California. We usually had about 25 students from Central Washington University packed in 3 vans, and this was always our stop after lunch in Bend on the first day. And so I have good memories of this spot, breaking in a group, people not knowing each other, nervous, all that stuff. And this was a good little first experience for many of our geology students. And we get up to this viewpoint and we would just give them a crack at thinking out loud, making some field observations. We chose to do a 2-week field class. It's still being offered, a 2-week field class at the sophomore level. So if a kid gets real interested in geology after taking a 100 level class, we'd say, well, let's have you jump in the van and we'll take you down to California. We'll do some geology for real in the field and teach you how to make geologic maps. And for some of them, that truly was the experience. They would just come right out here and do this stuff immediately. So this stop here at Lava Butte, part of Newberry Volcano, was just an excellent little first chance to get them out of the van, stretch their legs a little bit, but also just to kind of exercise a couple of basic points about being careful to make field observations and not get too crazy with interpretations, although most everybody wants to do it that way. But we'd have a little discussion, we'd have some geologic maps, and we'd try to get them to observe the cinder cone and then these lava flows and try to decide, if we could decide in the field from what we could see on a short little post-lunch walk, observations and relations between the lavas and the cinder cone. Who's older, in other words? Were the lava flows here first and then the cinder cone got built later? Or was the cinder cone here first and then these huge lava balls, snowballs of lava? Pretty impressive. Did these things come right out of that cinder cone, or were they established here before the cinder cone got built? Just like the big obsidian flow, this is a very user-friendly, great spot for families with young kids, and a great chance to see some very interesting volcanic deposits without a whole lot of effort invested. Highly recommend it if you haven't been here. US 97, the same US 97 that goes up and over Blewett Pass, blah, 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 in central Washington. I mean, I can hear the distant rumble of US 97 right here, so. We're not that far from Bend. We're not that far from civilization, and yet this is a really tangible, accessible spot. I think many of you know that cinder cone volcanoes, like the one on the horizon there, is just like it sounds. It's a cone made out of cinders. The cinders are small particles, pea-sized particles, sometimes bigger, very vesicular. And there's a vent there. And that cinder cone is like a hot air popcorn popper. And a very different experience than presumably identical lava. Down here, the lava is truly flowing over the surface in an effusive style. So in a way, it's like we're in Hawaii right now. Many of these levees of lava and spatter and bombs and other kinds of features are for sure a Hawaiian experience as well. Skies are still quite clear here in Central Oregon. We're very lucky to not be choked in smoke at the moment. So here they're giving it away. That some of these lava flows, apparently due to field relations, are saying that the cone, much of the cone was built, again, explosive and cinders popping into the air and then falling down to build the cinder cone, but that there was a breach on this south side of the cinder cone. And many of these lavas flowing at you were flowing out of the side, or I think more accurately out of the base, the south base of this cinder cone volcano. And you're like, well, I wonder why that happened. Why didn't it just continue to be a bunch of cinders? Why was there kind of a jailbreak of this very fluid lava? I don't know, and maybe nobody does. And if the sun is right, and if the skies are right, one of the really nice things at the viewpoint is realizing that this cinder cone is not alone. There's a very impressive family of cinder cones here, south of Bend. Dozens, maybe hundreds, of individual cinder cones about the scale of this guy up here. And if we pull back and talk about cinder cone volcanoes in the Pacific Northwest, that continues to be on my list. Why are there so many cinder cones? Apparently randomly arranged, although I guess you can make a case where many of the cinder cones that have been built have been developed on fracture zones or even fault zones. But I think another message is that the cinder cones are all Pleistocene, meaning, well, the cinder cones are all during the age of the ice. Ice Age cinder cones. None of them go back hundreds of thousands of years, to my knowledge. Well, they've really upped their game with their displays here. Very nice. It's been quite a few years since I've been here. Nice job by these guys. Lava tube, mostly collapsed lava tube. And back to the Geology 210 class. This was also it's a very short hike, 20 minutes, 15 minutes, all paved. Not a whole lot of relief. It was a first indicator of, if it wasn't obvious physically, like just who in our group is really going to struggle, because when you are doing field geology, you're doing a lot of hiking. You're dealing with a lot of uncertainty, physical and mental uncertainty. It's stressful. And if you're just unable to walk up modest slopes, then this first little walk is like a little litmus test. Like, okay, this person's going to really struggle. And to some of those students' credit, who we would earmark on this first day is like, okay, we got to watch Larry here. He was laboring back there at Newberry, let alone out here in the desert down in Newlands Valley, where we got to go up this flank of a cinder cone at Fish Springs, down by Big Pine, which was one of our mapping areas. To the credit of the Larrys of the world, even though it was a struggle, by God, they were stubborn. They were not going to be denied. Men and women. You couldn't really predict it, but some of them they worked hard, and they knew it was not easy for them to get around physically, but they were determined not to let their partner down and to learn what they could. So hats off to them. So I've always been here at about 1 o'clock in the afternoon. I've never been here at sunset. Kind of always wanted to, so it's nice to be here with you today. I mean, in a way, it looks like these flows happened yesterday. Look at how they just go right up to the edge of that forest. And you can just visualize how many more trees were here before these eruptions. Did you catch a date? Did they give any date for these eruptions here? Is this the same 1,300 years ago thing that the big obsidian flow was?
I think it was 7,000 years.
7,000, even, no, not even younger. Okay, 7,000. Still pretty fresh. So I remember these discussions. We'd have these students standing here, pretty wet behind the ears, hardly any of them being at a place like this before. And we'd first start by saying, just what observations can you make here? It can be a big observation, it can be a small observation. What do you think? And some kid would go, well, there was an eruption over there and this lava came through here, and of course that was older than that. I'm like, well, let's hold off now. None of those are observations. We're going to get to you in a second, Chester, but we just want to make some observations now. So they'd start observing that hill is higher than this hill, and that hill looks like it's made out of a bunch of small little particles of things. Somebody says, I think we'd call those cinders, right? Yep. And they'd say, can you really drive to the top of that thing? I'm like, yeah. And they're like, well, why didn't we drive to the top? I was like, well, kind of like this spot better. And does not disappoint. Scott from Chico does not disappoint. So we go through the observations. There weren't nearly the display signs that we stopped at on the way out here. Again, that's pretty new, I think. And then the heated debate would be who's older. And it would be real interesting to hear from this vantage point people really weighing in. Well, obviously the stuff down here is older because it's lower than that stuff over there. I was taught in 101 that the layers at the bottom are older than the layers at the top. And then there's a little silence, and somebody will just go, well, I'm sorry, but I wonder if that's true here. Because why couldn't that whole pile of cinders just pop up in a relatively short amount of time on top of these lava flows? And somebody else would chime in. So are you saying these lava flows in front of us here go underneath that cinder cone? And the person goes, well, maybe I'm saying that. I'm not sure. Maybe. And then somebody would say, well, wait a minute. Look there to the south. There's like 7 more of them. I wonder if all these cinder cones are the same age. And then somebody will go, well, are those cinder cones way over there then? And then somebody goes, oh no, those are the stratovolcanoes of the Cascades. So, also it would be a litmus test on what kind of group we were going to spend the next 15 days with. Was it going to be a fun group? And they're like automatically turned on and talking to each other without any prompting? Or was it going to take a little bit more work to get some comfort with the group? And then somebody want to talk about this feature right in here. What is this? You get the idea. You guys take your time. I'm going to mosey my way back and maybe film a little more. Can you hear the traffic of US 97? Kind of takes away some of the ambiance, but still a pretty nice spot. No obsidian to be found here. So if you saw the previous video, that's from Paulina Lake and the Newberry Volcano caldera. High silica lava, rhyolite, obsidian, explosive, caldera, that whole thing. There's a few cinder cones down there, but it's same volcano. It's really kind of really interesting contrast. And it's like a 20-minute drive from here. So if it didn't make sense in the last video where I said Newberry Volcano was kind of a, whatever I said, kind of a schizophrenic volcano, or it's not a simple set of lavas for Newberry Volcano, maybe this second video from the Newberry scene can reinforce that what you're seeing here is the same volcano as that big obsidian lava flow in that large circular Newberry caldera. And again, the confusion for me, and maybe geologists as a whole, is why such different kinds of lava are part of the same system. And just in general, I'm getting more interested in the variability in size of magma systems in the Cascades.
What is it?
Hi.
Hi. I'm done.
It's a beautiful evening. You're almost there. So, I'm just starting to think about this kind of stuff. Maybe you know more than I. But there are some pretty big caldera structures in the Cascades. Up by Bellingham, up by Mount Baker, there's the Colshan caldera. I don't understand why that's there at all. Which I assume is on the same scale and the same kinds of high silica lavas as the Newberry caldera. Tectonically, what's going on? Is there truly a different story there? Or if we take the Michael Eddy approach, and Mike Eddy last week or 2 weeks ago at the campground kind of said off the cuff, he says, I'm kind of interested in a lot of these batholiths in the Cascades. Like, how about the Snoqualmie batholith? I'm not sure anybody's looked carefully at the Snoqualmie batholith, which is an incredible volume of granitic plutonic rock. I'm not sure anybody's looked at it in the last 30 years with his techniques and his abilities to really study the details of a magma system. Maybe a guy like Mike Eddy will help us realize why there's such variability in volcanic styles, volcanic products, volcanic volumes, and ultimately why there's such an incredible variety of volcanic hazards just in the Cascade volcanic system. I've always just talked generally about that, but I never really have much specific to offer, so I'd like to learn more about that. And Newberry Volcano is a place to start, I suppose. These places are all unique. I can't help but think of Randy Lewis and almost everywhere I go now, and any unique landscape like this, I immediately now think about where were the villages here? Where were the lodges here? Was this a winter camp? Was this a summer scene? Because they were attracted, like everybody else is attracted, to these places that are grand, unique, magical, whatever the right adjectives are. Again, coming at this geology stuff from a kind of a different angle. Oh, that's a nice shot of Bachelor. Can you see it? That beautiful stratovolcano just to the left of the sun. Not sure how well that shows up for you, but oh yeah, that's good stuff. It's a nice shot.